If you think AI models all work the same way, then stick around because this video is for you. Because in reality, they don't, and it's not even close. Most of you will have already come into contact with AI models by now. ChatGPT, Gemini, Claude, Grok, whatever your platform of choice is. And it's easy to assume they're all roughly the same, right? Well, they're not. If you treat them as interchangeable, you're already misunderstanding the landscape. Each one comes from a different doctrine and behaves accordingly. They might produce similar outputs, but under the surface the differences are structural. Architectures, training methods, compute budgets, alignment strategies, none of it matches, and those differences shape everything that follows.
You're watching Burst Comms.
These systems don't just differ technically, they differ in how they handle your data. Some isolate it, some log it, and some analyze metadata. Some leave it to whoever deploys them. And in this video, we'll break down each model in the same way. How it's built, how it behaves, where it fails, and how it treats your data. Let's start with the model that defined the category for most people, ChatGPT. GPT is what's called a dense transformer. Every parameter fires on every token. The approach gives GPT its coherence and stability across almost anything. Writing, coding, logic, long reasoning chains, creativity. But because the whole model fires every time, it burns compute energy aggressively and becomes expensive to scale. GPT still sets the general purpose standard, however. But on a deep scientific benchmark like GPQA, it's no longer the only one performing at that level. OpenAI splits data policy by tier. Enterprise and API users get strict isolation. Their prompts aren't used for training. Consumer users still generate behavioral signals unless they disable it. OpenAI doesn't sell your data, but it does use parts of it to refine future models. On the free and plus plans, you leave metadata unless you turn it off. On enterprise plans, nothing you write is touched. So ChatGPT's strengths are coherence and reliability. It handles almost anything with stable reasoning, and its mature training pipeline shows in how consistently it behaves. With the largest ecosystem and the easiest deployment options, GPT remains the all-purpose workhorse. But the weaknesses are structural. Dense models are expensive to run, they scale badly, and they're exposed to ongoing legal challenges. And GPT has been slower than others to adopt newer architecture styles that activate only the parts of the model needed for each task. So what is ChatGPT best for? Well, GPT is best when you need a dependable all-rounder. The model that can tackle almost anything without falling apart. Google's Gemini sits on a different axis entirely. Google built it to treat the whole digital world, text, visuals, audio, as one continuous stream of information. Gemini is built for multimodality inside Google's vertical stack. The hardware, OS, and apps all feed into it. It's extremely strong at mixed input reasoning and long context tasks. Its best performance happens on Google's custom hardware across Workspace, Android, Chrome, and Search. Google is a behavioral analytics company. Workspace enterprise users get isolation, but standard users still feed metadata. Context, timing, feature usage all goes back to Google's wider system. Whilst your prompt content isn't used for training, the signals around it still feed Google's analytics engine. Gemini's strength is its multimodality. It handles text, images, audio, and video as one unified language, which gives it a clear edge on tasks that mixed formats. It also holds long context well and benefits from Google's enterprise tooling and hardware acceleration. But its advantages are tied to Google's ecosystem. It performs best on their infrastructure. Adoption outside of that environment is slower, and the whole strategy leans heavily on centralization. It's good for integration, not for flexibility. So overall, Gemini is best for anything multimodal or mixed format, such as situations where text, images, and audio and video blend together. Claude approaches intelligence cautiously. Anthropic designed it with a single priority: keep the model stable, predictable, and grounded, no matter the task. Claude is built around controlled alignment. It uses something called constitutional AI to stabilize its behavior. This gives Claude a very low hallucination rate and excellent long context structure. It's reliable across large documents, analysis tasks, and summarization. Its limitation is caution though. Claude refuses tasks that other models will attempt. On a positive note, Claude has the strictest privacy posture of any major model. It doesn't train on user data by default, even in the free tier, and logging is minimal and retention is, thankfully, short. In practice, if you ever care about your privacy, Claude interferes the least. Claude's strengths are stability and discipline. It hallucinates less than any major competitor, holds structure across extremely long inputs, and behaves consistently because of its alignment-first design. But that caution creates friction. Claude is overly restrictive at times. It's weaker in coding tasks, and it struggles when the task is messy or open-ended. It stays safe even when you want it to push further. So Claude's best use case? Well, Claude is best used for structured thinking. Long documents, analysis, and anything where stability and accuracy matter more than the risk-taking. Grok doesn't bother with caution. It's engineered to move fast, think aggressively, and react to the present moment in a way no other mainstream model attempts. Grok is built for speed and aggressive reasoning. It performs extremely well on the hardest logic and coding benchmarks. Its defining advantage is real-time awareness. It's the only major model with access to live global sentiment via X, and alignment is intentionally lighter, which creates volatility. Grok runs inside X's real-time telemetry environment. Enterprise users can isolate data, but consumer usage inherits the platform's analytics-heavy design. So in practice, Grok captures more behavioral metadata than all of the others. Not content, but activity signals. In terms of its strengths and weaknesses, well, Grok's strengths are speed, sharp reasoning, and real-time awareness. It consistently tops hard benchmarks and compresses long thinking tasks efficiently. And with the live data feed, it has situational awareness no other model can match. But its alignment is lighter, which makes it unpredictable. The tone can swing. Enterprises hesitate because of stability concerns, and its multimodal abilities aren't as strong as Gemini's. So in summary, Grok is pretty smart, but a little bit unpredictable. And in terms of what is Grok best for, well, Grok is best for hard reasoning under pressure, logic-heavy tasks, coding, and real-time awareness when speed is very important. Llama. Llama belongs to a different world, the open one. It's a model you can actually hold, modify, or run yourself, and that alone places it in its own special category. Llama weights are open, anyone can run it, customize it, or deploy it offline. And this creates sovereignty and flexibility, but also huge variability. Quality depends entirely on who trained the version you're using. Whilst the model itself actually logs nothing, but any company deploying it can collect anything: prompts, outputs, metadata. So privacy is determined by the operator, not the model. Run Llama locally and your data stays with you. Use someone else's Llama service and you're trusting them, not Meta. Llama's strength is freedom. You can run it on your own hardware, fine-tune it without limits, and deploy it without paying API fees. It has a massive ecosystem and gives organizations total control. But the weakness is its inconsistency. Open ecosystems produce everything from excellent models to broken ones. It's not frontier level in reasoning, and its alignment varies wildly between versions. Best use case for Llama? Well, it's sovereignty. Full control, local deployment, custom models, and environments where vendor lock-in isn't an option. Mistral. Well, Mistral isn't chasing scale for the sake of it. It's built around precision engineering, smaller models that punch above their weight because the design is sharp. Mistral focuses on efficiency and routing intelligence, activating only parts of the model needed for each token. Its goal isn't frontier intelligence, but scalable, affordable performance for automation and agent workloads. Mistral follows the same open source infrastructure philosophy as Llama. The model doesn't harvest data by itself, but deployments vary. It can run locally offline or inside heavily observed environments. Mistral can be totally private or totally monitored. It depends entirely on who runs it. Mistral's strengths are its efficiency and speed. Its routing design is clean, economical, and ideal for automation in real-time agents. It's stable and cost-effective at scale. But it's not aiming for frontier cognition. The ecosystem is smaller, visibly weaker, and its global footprint is still forming. So what is Mistral best for? Well, efficiency and automation. Basically agent workloads, low latency systems, and anything that needs speed without massive compute power. Which brings us on to the last but not least, DeepSeek. DeepSeek is the shock to the system. A reminder that optimization can beat brute force. It delivers high-end reasoning at a price that rewrites the economics of AI. DeepSeek is aggressive industrial optimization. Its latest frontier model reportedly cost around $6 million to train, far below the US competitors. It uses sparsity, fused kernels, and hardware-level memory optimization. The result is high-end reasoning at a dramatically lower price. The model doesn't harvest data by itself. Local deployments can be fully private. But Western organizations treat Chinese origin software as higher risk, regardless of any technical safeguards. Run it locally and it's private. Use a cloud endpoint and you enter a different regulatory environment. The risk is geopolitical, not technical. So what are DeepSeek's strengths? Well, it's cost performance. It delivers strong reasoning with highly optimized architecture at a fraction of the usual compute budget. It iterates fast and represents a different economic model for building frontier systems. But the limitations are political, not technical. Government concerns slow Western adoption. Transparency is lower than US models, and cloud usage, that would raise significant regulatory caution. So best use case for DeepSeek is cost performance and strong reasoning. Fast iteration where budgets are tight and efficiency is paramount. So once you line these systems up, the bigger picture becomes clear. 7 different strategies trying to solve intelligence in 7 different ways. ChatGPT is the absolute all-rounder. Gemini owns multimodality. Claude offers stability, Grok delivers real-time reasoning, Llama gives you control, and Mistral gives you efficiency. And then there's DeepSeek. It gives you power at a price, and that's a price nobody expected and possibly nobody fully understands. The ecosystem isn't converging, it's diverging. Different doctrines, different trade-offs, and different implications for your data. So, the era of one dominant system is gone. These models are increasingly specialized now, and the people who get the most from them will be the ones who understand the difference and use them accordingly.